Okay, recording started, June 19th, study hall. We're going to be doing some quant problems, data sufficiency that involve testing cases. We have just finished going through the rules. And here, again, the two administrative notes, multiple choice questions. Please use the answer choices that are here. And these problems are from PrEP. So they are copyright GMAC. These are from the free part of the PrEP software. So that is what permits us to use them, but as long as we carry this copyright, that is along with that. And notice these are going to be data sufficiency problems. So we do expect that you know what the answer choices to data sufficiency are. If any of you don't know those, I can sort of type them up on one side of the board, but we do expect that you are familiar with the basic functioning of data sufficiency problems. Okay, here is a problem. And again, don't forget where you will find multiple choice question responses. That would be here. Give this a shot. Okay, there's still a couple of you who don't have answer choices selected, so please pick something. As you're doing this, don't forget the way this test operates. There's no such thing as not picking a choice. So please try to simulate that as much as possible when you're taking these problems. There are no non-responses. In any case, we are all over the place on this one. There's a very almost randomized distribution of answers here, so this will be interesting. But let's start talking about this. And no matter what the theme is with data sufficiency, when data sufficiency is the topic under discussion, a lot of people have the same issue with it, and they've had the same issue for a period of months that they've been studying. And because people are so focused on content, they don't really think procedurally. But if you think about it, what the issue really is with data sufficiency is that it's this brand new, weird type of problem that you've never seen before. And what makes it hard is that it's strange and procedurally unlike what you've done before. So when you look at a data sufficiency problem, when you first see one, what you have to understand is you have to understand what the goals are. Like what the goal is. What are you trying to do in the problem? So always translate and identify the goal first. So two things. The first is translate yes and no if it's a yes-no problem. So it's not, if it's find this value, you don't have to translate that. We'll talk about what that means in a second. And then make sure you identify the goal of your thought process. Because these are what people don't do a lot of the time, and because they don't, they continue having issues with data sufficiency for a very long time. So translate. What I mean by translate is, and I mean it's not a difficult type of translation to do, but it helps you get a finger on exactly what it is that you're trying to accomplish with these problems. What I mean by translating is into specifics. Because the problem with yes and no is that they are not really goals and they are not really things that are in the problem. You can't do a bunch of mathematical work and then suddenly have the word yes or the word no pop out. So you don't really want to be dealing in the currency of yeses and nos. What you want to be dealing with instead is concrete things that you can accomplish or not accomplish or find or not find. So let's translate. Let's do a little bit of translating here. The question is z greater than 4, or is z less than 4? So translate. What does a yes mean to this question? Yes means that z is what? Z means that z is less than 4, sure. And what does no mean? No does not mean that z is greater than 4. It means that it is greater than or equal to 4. There are problems where they will get you with that, so you need to be really careful. And then what is the goal here? Are you trying for sufficient, or are you trying for not sufficient? And then someone mentioned these numbers from -3 through 3. There are actually two things wrong with that. The first is that these don't have to be whole numbers. And the second is that there's no reason to have two boundaries like that. This is not an absolute value problem. So, what are we trying for? I mean, let's define, so we define yes and no. Now we define sufficient and not sufficient. So, sufficient means that you are stuck with one of these. On the other hand, not sufficient means you can get both of these. Sufficient means you can't. And so, if you think about this again, I mean, we've made this point in several of the study halls before, but probably because the problems are called data sufficiency, they're not called data insufficiency. So you have this bias when you first look at them toward thinking that sufficient is some kind of goal or some kind of thing that you want to keep in your sight. But if you think about it, getting both of these things to happen is a concrete outcome, whereas being stuck with one is not. Like, being stuck with one is actually failing to get both. So sufficient actually, in these kinds of problems that are yes, no, really, you're trying to get both, and if you fail to, then it's sufficient. So your goal is actually this. Your goal is to try to get both of these outcomes. And this is going to be consistent for yes-no questions. Your goal is going to be not sufficient. So this is your concrete goal that you are trying for. And it helps to put reminders below the statements, too. Let me show you what I mean. So, okay. Statement 1, by the way, what do we do with this part? What do we do with this green box part? The if. Blah, 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 blah. Can anybody tell me what that means? It's more specific than one of them is negative, because this is actually a -3. If it said that ZT less than 0, then that would be mostly a statement of signs, but this is actually an inequality that should be considered as an inequality. But before you start doing math with it at all, what does it mean to stick it behind that if? Like, how does it apply to the statements? When is it true? It's true always. So what you can do, when there's an if statement, you can kick it into both statements because it's true both times. So let's just rephrase the whole thing in terms of that. That way, because I mean, it's kind of annoying when half of your givens are in the question and half of them are in the statements. I mean, at least to me, that is sort of confusing to have to look in two places all the time. So really the question is just this. And you don't even necessarily need to look at that question anymore if you understand that this is your concrete goal. But then here are your two statements. Statement 1 is z is less than 9, but also we know at the same time that zt is less than -3. There we go. And then statement 2 is t is less than -4, but then we also know that this is true again. And this is probably an easier way to think about it, only because you are not looking in two places all the same time. So, okay. So let's do some stuff here. And I mean, to make sure your eyes are on this concrete goal, what I find helpful for people who are new to this, or for people who are not new to it, but who still get confused or lost procedurally, is to put those two goal things down and then see if you can circle them or cross them out. So those are the two things you are trying to accomplish. If you can circle both of these, that's not sufficient, and if you can cross one of them out, then that's not sufficient, then that's sufficient. So, okay. Can you get z to be less than 4? Subject to these two conditions. You cannot get z to be less than 4? Sure you can. I mean, give me an example. Just pick a number, maybe not any number, but z can be 1 and t can be -5. Sure, that works. Exactly. So if you have z equals 1, let's just make a table, z, t, z, t. So if z is 1 and t is -5, then zt is -5. That works. And z is less than 4. So we got that. That case doesn't actually work because zt has to be less than -3. It can't be -3. It has to actually be less. So once this happens, what is our only goal in life? What is the only thing we are trying to prove? What specifically? No, you're not finding where it's not less than -3, no. If you had zt being more than -3, you would just ignore it completely. So these are conditions. You're not trying to violate the conditions. You're trying to get these are the two things that you are trying to get to happen, these two things right here. I mean, you can't, it's not yes or no this. And this is why you don't, that right there, that is why you don't leave yeses and nos as yeses and nos. Because you get totally confused as to what you are trying to say yes or no to. It's not concrete. But if you realize these are your two goals, then there's no mistaking, okay, we fulfilled this one. And so now we have to fulfill this one. So sure, we can just try 5 and -1, and that'll give us -5 as well. And now we got that one to happen too. So we circled them both. We got them both to happen, which means that it's not sufficient. There we go. Any questions about this? Okay, again, here are your two goals that we are trying to accomplish. Put the question marks on those again. That's what we're trying to do. So t is less than -4. These are both givens. So can we get z to be less than 4? Angelica suggested on the last problem that we can use 0 for z. That's kind of a good idea. Because then, except for 0 is not less than -3, so it won't work here. But 0 is a nice, simple place to start your reasoning. Unfortunately, we do have to be less than a negative with our product. So 0 can't work here. But it's a good first try in general. what are some z and t values? Notice that z can be kind of anything as long as you make this happen. Yeah, you can still keep this case. So in the interest of laziness, if any cases from the previous statement work, you might as well carry them over. So that'll work. Still true that, I mean, both, well, that still satisfies this. So we can still get z to be less than 4. Now let's try to make z bigger. Rachel, both of those statements would be z less than 4. So, and one of them would not satisfy the condition either. So remember to keep the goals in mind. Like, what are we trying to accomplish now? What? We're trying to get what again? Yeah, we're trying to get z to be 4 or more. So if we try z to be something like what? Sure, like 5 and then -2, because then zt is -10. That satisfies the condition. And then you've got z greater than or equal to 4. You can't do -2, that's true. But you can do something like -5, that works. And then you have -25. And so now we thank you. Now we have this satisfied. Got them both. Not sufficient. And then we try to combine them. So notice if you combine them together, now we know both items and we still know the green thing. So together, now there are 3 conditions, which are z has to be less than 9, zt has to be less than -3, and t has to be less than -4. But if you look at this, we actually don't have to do any more work, because these 3 conditions, perhaps by accident, are all satisfied here. Like in both of these statements, z is less than 9, and then we know the other 2 are also satisfied because they were there to start with. So these 2 satisfy both of the statements together, and you still get to circle both statements. So you can use the exact same cases. So still not sufficient. So this is going to be E like elephant. Any questions about this problem? In general, when you have inequalities, you can't really divide or multiply them unless you have very strict conditions on things like signs, which we don't. I mean, if you look at these, we don't have sign restrictions. I mean, you can pick lots of things as far as signs go. So algebra is not really a thing on this problem. But this testing cases approach is pretty well suited to yes-no questions, probably much better suited than algebra in most yes-no questions anyway. But notice I mean, there were a bunch of people who had trouble with this one. Even during the discussion of it, a lot of people had the wrong goals in mind. And that tends to be what the issue is with data sufficiency in general, but especially with yes-no data sufficiency. So that tends to be the issue. I mean, even once we had laid this all out and had this explicitly on the page, there were still people trying to make zt not less than -3. It's not the goal. The goal is this and this. And you can write that however much or however prominently you have to write that on your page to get yourself not to forget that that is the goal. If you're given Where are you getting 3/4? 3/4. 3/4 is coming from where? If you just think of t equals -4, then, well, does that have to be true though? Because you could less than -4. You could have z be like negative less than -3. I mean, z could be like 0.001 if t were minus 100 billion zillion. So that 3/4 lower bound on z doesn't really work. In general, you're going to have a very hard time trying to do this kind of thing with algebra. It's much better to just try to test cases on things like this. But you see that's a counterexample of that. So whatever gave you that boundary isn't really a thing. The only thing you can really easily do with inequalities that have the same inequality sign is add them. Like if you have something less than something else and another thing less than another thing, then you can just add those for sure. But other combinations tend to be fishy, especially division. Division is very notably awkward when you have ranges of numbers, especially when there's more than one sign. That gets awful pretty quickly. But okay. The point, back to this, when you test cases with yes, no's, you got to translate the yeses and no's. You have to know what you are trying to do in the first place. You have to not lose sight of what you are trying to do. I mean, including visual reminders, if possible. Visual reminders are your friend. Okay. Let's move on if possible. We don't have to test new cases because you can test these cases again. Same cases as we used in statement 2. They still work because they still satisfy everything. So the same work, this exact same table of cases also counts for together. All right, let's do something new. I don't generally post the polling results because there's not much of a point in doing so. I mean, as far as your individual progress doesn't really depend on how others are doing. So try this one. This one should be quick. I'll give you a minute. You can take a little bit longer if you need to. There's still some people without answers, but shouldn't take too much longer. JSB, if you make that a more specific question, that would help. I mean, nothing's been rephrased yet in this problem, so I'm not sure what you're asking. Exactly. Okay, there's still about 7 or 8 of you who don't have answers yet. So, well, what we're doing there is just saying what yes and no mean so that we have goals. Because again, I mean, in a sense, you're always doing the same thing in yes and no questions, but not really. I mean, you are always trying for yeses and nos, but the problem is that yeses and nos are not meaningful as yeses and nos. what we're doing is we're translating. So here's the old question screen. I wouldn't call it a rephrase. It's not a rephrase. We're not really changing anything. We're just, it's that. What we're doing is that. We're just saying what yes means and what no means in the problem at hand. Because the problem is that people have no idea what they're trying to do. So what you have in the chat box there is almost right, except for it should be greater than or equal to 1. Because x plus y equals 1 would also be a no. So this one, the polling results I think I'll put this time because it's an interesting pattern. Here's what you guys have as a class. Mostly C's, some E's, and then these might just be mistakes, but we'll see. So this one is probably someone thinking that D is actually C. Remember, D is that the individual ones alone solve it. And then maybe this person is thinking that B means you already have the first one. Remember, when you look at the second statement, you don't have the first one yet. But let's take a look. So always do the same thing, which is start it out with translate yes and no. And then once you have translated yes and no, state explicitly what your goal is. And I mean, also, here's the other thing. Like, people look at these problems, and they think things like, okay, well, this problem makes me sort of antsy or nervous or whatever. And I mean, a big part of doing away with that kind of anxiety comes from just having a solid plan of something to do. Because, like, that feeling, more than anything else, comes from just looking at something and not knowing how to start it. But if you do this is a way to start everything all the time. I mean, translate stuff, state the goal. So, yeah, it does have to be greater than or equal to. We touched on that. It's true. So the yes in this problem means that x plus y is less than 1. And the no to this problem would mean that that is not true, which means that it's either equal to 1 or it is more than 1. And then your goal is to try to make, again, if you can make both of those happen, that's not sufficient. And if you cannot make both of these happen, but if you're stuck with one, if you try to make both of these happen and you fail, then that's sufficient. So again, only this, really the not sufficient is always the goal here. You want to try to get both. X plus y is greater than 1, and x plus y is not greater than 1. Okay. Well, so the individual statements, if you understand that this is your goal, this should really not be so bad. X plus y greater than 1, question mark. X plus y less than 1, less than or equal to. Again, visual reminder. Our goal is to try to get both of these. So make that box underneath each statement and then see if you can circle both of them. That's basically what you're trying to do. Okay, if you have these individually, this is really not so bad, because y can be anything at all in the whole world in statement 1. And I did get them wrong. Left and right facing things are not my favorite strength. Thank you for that watching set of eyes there. That is very true. Okay. Then that's also a thing. It's a very common mistake that people make. So that mistake that I just made is a mistake that lots of people make. So what you want to do is always triple and double check any sort of inequality signs that face left and right, because that's an all too common way that people miss entire problems. They do the kind of thing that I just did right there. So absolutely, yes, that was a mistake. All right, so those are the correct things. Those are the goals. All right, so individually in statement 1, I mean, we don't really need to test specific cases here because y can be any number in the world. So that means it's going to be very easy to get both of these. I mean, y can be positive a million or negative a million. In this statement, x can be any number at all whatsoever. So this is going to be, again, very easy to get both of these. Now, let's look at these together. These are still the goals. I mean, one of these is quite easy to get, which is x plus y less than 1. I mean, there are lots and lots and lots of ways to do that. So, for example, if they're both 0, then, yeah, zeros are a good place to start. So this is pretty easy to get. Now, once you've done that, what is your only goal in life? To try to get what? To try to get, yeah, where are those numbers coming from? You're trying to get that. So you only need to think about one thing. I mean, this is your only goal now. And to get this, since you're just adding 2 numbers, there is absolutely no point whatsoever in thinking about anything other than the biggest numbers you can get your hands on. So just think about the biggest numbers you can get your hands on. So sure, you can add these, although that's not always possible all the time. So you want to be careful with that. I can think of some examples here in a moment. But all right, so think about the biggest numbers you can get your hands on. Well, you can think of them in terms of fractions or in terms of decimals. So in fraction terms, you don't need to think about weird-looking fractions, because you can just realize that x can be anything less than 8/9. So it can be like, it can be 8/9 minus 1 trillion. Yeah, so you can just think of x can be approximately 8/9. I mean, 8/9 minus tiny epsilon, 8/9 minus 0.001. So, I mean, you realize that you cannot achieve the value of 8/9, but you can get absolutely as close to it as you want. And then y can be approximately that limiting value of 1/8. So, therefore, x can be as close as you want to 8/9 plus 1/8. If you think about common denominator, that's a common denominator of 72, so that's 64 over 72 plus 9 over 72 is 73 over 72. Again, you cannot achieve the value of 73 over 72, but you could be 73 over 72 minus 0.000000, whatever. So this is bigger than 1, and that proves that you can also get that case, which means not sufficient. In terms of decimals, a lot of you guys are converting to decimals. That's definitely not a terrible idea. That might make it easier for you to see. It might make it easier for you to think about approximating these with much closer numbers. So 8/9 is, if you long divide it, it's about it's a repeating 0.88888. And 1/8 is 0.125. So if you just pick numbers that are very, very close to these, like 0.888, you can use x is 0.888 and y is 0.124, then x plus y is more than 1. So you can get these, and that is E overall, E like elephant. Question in the text box, if y was less than 1/9, then it would actually be very easy to see how the problem turns out, because 8/9 and 1/9 is 1. So if you had less than 8/9 and less than 1/9, then you would very clearly have to have less than 1. So that is the answer to Pete's question. The answer is you can get both of these, so it's not sufficient. It's E overall. The answer is you can get a yes or a no to the original question. You can make x plus y less than or not less than 1. Let's see. Yeah, Angelica, there are always fractions that are between any number and any other number at all. So basically your question is like, are there fractions between 1 and 73 over 72? Sure there are. And then once you have one of those, there will be fractions between those two. You can just, yeah, as we noted, the answer is E. You can just average two numbers, and you'll get another fraction if they are fractions to begin with, right? Because like if you add two fractions and divide by 2, you'll get another fraction that is between them. No, the answer is not C, because if you have the two statements together, you can still get both cases. Does that make sense? We got both of these to happen still with the two statements. So no, not C. It should be E. You still have, if anything is still unclear about that, feel free to ask. A couple people are typing. See what you're typing. Okay. Not typing. Yes, typing. Okay. Let's move on to another question. Let's try this one. All right. There's still a lot of you without answers to this one. Okay. You have to guess, make a guess. We have almost equal numbers of people picking A, C, and E here. So it's if you are guessing, there are definitely a lot of others guessing along with you. So, okay. Let's take a look. If you don't have an answer yet, remember this is not the kind of test that works. You can't not answer things. So just remind yourself of that constantly. Okay, this is not a yes/no, but you still want to make sure that you understand what the goal is. So if you think about it, maybe imagining a number line can help you. So if you have, here's a number line, and then here is, like schematically, let's say that X is here and Y is here. Then the deal is, if you imagine other points on this number line being integers, the question is these other points in between them as orange points. I mean, I have to draw a certain number of dots, but the point is that there could be lots of different numbers of dots in between them. So there are some dots in between X and Y, and the question is how many of the orange dots are odd? So, I mean, I tend to be biased towards visual interpretations of stuff, so thinking of it that way helps me. If you are less visual, then you might think in other ways that are appropriate to your strengths. But if you do like visualizing things, then this kind of way of visualizing this might help. So if we can get different, I mean, it should be clear that you're not really going to do this with algebra, but you're going to test cases. And again, as always, the goal when you test cases, the goal is not sufficient. But let's figure out exactly what that means here. So let's figure out what that means. What does that mean? What does not sufficient mean? You can get different numbers as the answer to that question. So, yeah. Actually, authorship noticed this problem is not actually a GMAT prep problem. This problem is my my alternate version of a GMAT prep problem. So there is a GMAT prep problem that is a lot like it, but I sort of tweaked it a little bit to create this one. So authorship noticed there. Okay. Well, yeah, the goal if there's only one answer to this question, then that's sufficient. And then if you can get two numbers, I mean, really two or more, but as soon as you find two, you are done, then that's not sufficient. That's a typo. And again, when you think about goals, you can't really try to get stuck with one outcome. I mean, stuck with one outcome means that I tried to get more than one and I couldn't do it. So sufficient, again, is not a goal. Like if you have algebra, then this is a goal, right? Because you can try to get algebra to boil down to a single value. In fact, that's kind of the point of algebra. But whenever your approach is not algebraic, which is definitely the case here, if you're testing cases, this is not a goal and cannot be a goal, because this is only what happens when you fail to do this. So let's take a look. But this is the goal. I'm trying to get two different numbers. So statement 1. There are 6 even integers that are greater than x and less than y. So that means that 6 of these dots would be odd. So let's just draw a number line there. I mean, we can just pick a random x and then just make dots until we get that. So let's try, give me an x. All right, let's try x as 1. So let's put a dot there. There's a dot. Okay, now let's just put orange dots and just see what, we'll put them there until we have to get. You guys are so impatient, I swear. Is it C? Is it E? Is it C? Is it E? I mean, we're getting there. Remember, the procedure is the point. Not the answer. The answer is not really important at all. What's important is how you get it. Okay. Dot, that's 3, that's odd. That's 5, that's odd. That's 7, that's odd. That's 9, that's odd. That's 11, that's odd. That's 13. Okay, so these are the odds. 3, 5, 7, 9, 11, 13. And then just to make it clear that 1 is the x. It's actually not one of the between dots. So let's just color code that accordingly. All right, now the deal And then those are not odds, those are evens. So the evens are 2, 4, 6, 8, 10, 12. Now, so this satisfies the constraints. That's a really thick arrow. Let's try it again. This, so far, we have satisfied the constraint because these are our 6 even integers. So, but do you guys see what the deal here is? Like if I put y here at 13, this can be y. So if y is this value, then the answer is there are only 3, 5, 7, 9, and 11. So there are 5 odds in the middle. But then I can also put y. So let's color code that as a possible y. But then I can also move y over without including another even. Because the constraint only constrains the number of evens that I can include. So if y happens to be the next value over, then there are 6 odds in the middle. So this is not sufficient because we got 2 things to happen. All right. Yeah, we'll get there. So you can also move the left-hand boundary, and so we're going to do that once it becomes necessary to do that. Statement 2, it's without, you can do statement 2 pretty quickly without even counting. Like if x is say 1 and y is 2, then there are 0 odds between them. If x is 1 and y is like 1,000, then there are lots of them. So lots of them is not the same as 0. So that's not sufficient. P-dub, what condition are you referring to? I mean, if you're referring to the fact that x and y have to be integers, that's why we're only making x and y integers. So, yeah. Number of odd integers. The number of odd integers doesn't have to be greater than x. It's just the integers themselves have to be greater than x. So, that's... If it were that, it would be that would be phrased as the number of odd integers is greater than x. If it says how many, that's how many individually are that. It's like the way those words are used in normal everyday stuff. Like if I say how many people in this room are over 40, you don't add everybody's ages up and see if they're over 40. You just see if individual people are over 40. And this is the same thing. So this is exactly the same as how many people in this room are more than 40 years old. It's not, you don't add them up. So the good news is that the real life usages will usually just transfer perfectly like they did there. Okay, let's see. So together, well, we can piggyback on this. How can we do that? Well, y minus x is odd. So, how are we going to get that to work? Well, if we look at the example up here, the only ways you're going to get, these are your orange dots. You could, if you want there to be like 2, 4, 6, 8, 10, and 12 in the middle to satisfy statement 1, then you're going to be able to do that with 1 and 14. And you're also going to be able to do that with 0 and 13. More generally, we can just write O's and E's. The boundary numbers like X and Y have to be 1 even and 1 odd. So what you're looking at here is X can be odd, and then you have to have 6 evens in there. So that would be even, 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 even. But then you got to have another odd there so that you can make Y odd, or so you make Y even rather. So that is actually 6 odds in the middle. The only other way you can really do that is if X is even and Y is odd. But if you got your 6 evens in there again, it's going to have to be 6 OEs. So you're actually still going to have 6 odds. So this is going to be sufficient together because you can't get different numbers of odds. You can get different things going on slightly with X and Y, but the number of odds has to be the same. How could you assume that they are consecutive? What do you mean? I don't understand the question. Could be, I mean, when you say greater than something and less than something else, then you necessarily are talking about the things that are between them. And you are saying how many are there. So, I mean, if you really hate consecutive numbers, you don't have to count them consecutively. You could always count them in a different order, like 12, 2, 8, 4, 10, 6. There are still 6 of them. So, as long as there are 6 even integers. But then that's not the answer to how many are. I mean, if you just pick the ones from 12 through 19, then you are ignoring some of the ones that are. So, I mean, how many means how many. It means how many are there total in this range. Now, does anybody know, the original, honestly, I don't remember, unless I was looking at it. I have that kind of memory. Does anybody know what's going to happen if, here's what currently exists of this problem. Does anybody know what's going to happen if I take this one word right there and make it say even? Yeah, it's gonna make this really different, right? Then, because if you have like X is odd, because that means that's an O, not a 0. But you'll see that in a second. So you either have even or odd. So if X is odd, then you're gonna have to get your 6 evens. You're only gonna have 5 odds. And then that next odd number is going to be Y. But then this, if X is an even number, then you're actually going to need 7 odds. Because you're going to need 1 as a buffer there. And you're going to need another one as a buffer from Y too. So interestingly, you can't get 6 odds, but you can get 5 or 7. So this would be not sufficient because you can get either 5 or 7, but weirdly not 6. So this time it's E. So this goes to show, I mean, you can't really ever predict how these things are going to turn out. I mean, it doesn't, intuitively, you wouldn't expect that even and odd difference would turn out so differently, but you do. And Al, I don't really understand what you're asking, but this has nothing to do with things being consecutive, and it just has to do with how many things are in a range. Like if I said how many integers are between 3 and 9, you would say, well, 4, 5, 6, 7, 8, so there's 5 of them. I mean, it's just how many of them are there. It's got nothing to do with them being consecutive. They are there or they are not there. How many are there? Okay, Pete, if you can do that, that's kind of a useful way of extending problems, but make sure you do it only if you have a reasonably good grasp and are pretty confident in your understanding of what happens. Because remember, when you tweak the problem, there won't be an answer key. So unless you feel like you understand it well enough to derive value from it without any sort of answer key or guidance, then if you do understand it that well, it's a good next step to take. It's a very good next step. But if there's any hesitancy about that, then you might want to wait on it. Let's see. Anavarela, hello. If you have a question, feel free to type it. Okay. Let's take, if y was 16 and x was 2, in that case you would have, in the original question, there's the original question. What is your question? That wouldn't satisfy statement 2. So, yeah, the original question is answer C, and then the version where you replace this with the even has answer E. Okay. Let's try. There's still like 4 people typing, so I guess I'll wait a little bit. In the original question, let's see. 21 and 3 would not work because that would not satisfy either of these statements. 21 and 3, you would have all the evens from 4 through 20 between those, and that's actually like 9 evens instead of 6. So, Pete, why don't you? That's a good kind of thing to investigate on your own as an extension to this problem. You can play around with that and see what happens. I mean, Pooja, you have to, it doesn't really matter what the starting value is, but you do have to have the right numbers of things here. Like if this 1 is moved to like 101, then you can still do the same thing if these are 114 and 113. I mean, but everything has to slide over together because you still have to have these 6 evens in the middle. So, okay. For statement 1, that's basically, because getting 2 through 15 is like having 0 through 13 or 1 through, that would be 6 or 6 even. Yeah, that'd be fine. For statement 1, but not for together, because then 1 through 13 would, 13 minus 1 is not odd. So, P-dub, if it says there are 6, that means there are 6. That does not mean at least 6. If they meant at least 6, they would say at least 6. So if it says a number, it means it. Just like if somebody says, I have 3 children, they're not going to surprise you with, haha, I actually have a fourth one too, and I just didn't tell you the first time. I mean, I have 3 kids means I have 3 kids. This is the same sort of thing. So, again, more generally, there are no trick questions on the GMAT. It's actually one of the things that is very cool about the GMAT. There are never trick questions, ever, 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 ever. There are never words where it's like, haha, these words don't really mean what they look like they do. That never happens. So if you just take the most common sense interpretation of all the words, you will be right every single time. It's one of the things that is very good about this test. There's never trick language, ever, 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 ever. Okay, let's do this one. All right, there's still a lot of non-answers this time, so next 10, 20 seconds, you should pick something, please. Oh, sorry, I think I was off the mic. Okay, so when you have a visually loaded problem like this, even if you are very good at visualization, it still would benefit you to draw it, just because you don't just have to visualize. You have to visualize it, and then you have to do all sorts of things once you have visualized it. You have to think about goals, yeses and nos, translating those things, and then trying for them. So let's just draw it. So you have a circle centered at P, radius is 4. So, and then X and Y are somewhere in the same plane. So in other words, there's no same plane, just gets rid of the idea that you might have to think in 3 dimensions. So, and then X and Y are somewhere. So in statement 2, notice that they don't relate any of these things to the circle. So these could be, as far as goals, let's back up. Let's translate. Translate, a yes is Y inside the circle, and a no is Y outside the circle. And your goal, as usual, is to get both of those to happen, and that would be not sufficient if you can get both of those to happen. So, there you go. That's your goal. Get both of these. Okay. In statement 2 should be very fast, because 4 of you guys picked B or D, which means you definitely didn't define goals as well as you should have. Here are the 2 things you're trying to do. If you don't relate anything to the circle at all of these points could be absolutely anywhere. So you can have it inside the circle, you can also have it outside the circle. So this is not sufficient right away. Again, this statement should be immediate. If it's not, then, or if, heaven forbid, you actually picked B or D, which means you got this statement wrong, or if you thought it was sufficient, then you didn't set goals. Or you set goals and then you forgot about them. But this is important. I mean, because this should be very clearly, you don't know anything with circle. And then statement 1, you don't know anything about Y. I mean, the goal is to try to put Y in or out of the circle. So again, a lot of you guys thought, not a lot, but a few of you thought statement 1 was sufficient too, but you don't even know where Y could be anywhere. So again, both outcomes are immediate. And the same warning applies to this one as to the other one, which is if you didn't immediately get this. So let me actually revise that. Both individual statements should be immediate, the resolution of both of them. And if it's not, then you didn't set goals. Okay. Because ultimately we're thinking about the relationship between y and a circle, and the circle has to do with p. So if you don't have anything on y, or if you don't have anything on p, then you're not getting that. Okay, together, the distance between point P and point X is 4.5. Now the thing that's neat about circles is that you can rotate them and nothing changes. So you can actually put X in one place and that actually covers all possibilities of X. So X is a little bit outside the circle. It's half a unit outside the circle. So this is the only placement of X that we really have to think about. If that's unclear, then let me know in the chat box. But you see, if X was on top, you could just say your paper was turned sideways. So basically, by considering X here, we're actually considering every possible event, every possible placement of X, because circles can be rotated. Okay, so now the goal is, can you get Y inside the circle and can you get Y outside the circle? So, well, it's getting outside the circle is not much of a challenge. Actually, I did switch these at the very beginning here. These are actually supposed to be no and yes, respectively. Nobody called me out on that, interestingly. It doesn't actually matter because your goal is either get both or not get both. So even if you switch the yeses and the nos, you'll never get a problem wrong for that reason. But yeah. Okay. Yeah, it's get both or that's right. That's what it is. So fortunately, that would be another annoying thing if it weren't. If it were like less than or greater than. So getting Y outside the circle, this is pretty easy to do. I mean, you can just put Y way over there. This is not to scale, but if Y is all the way clear on the right, then that's going to be outside the circle for sure. So, okay. Now you want to try to get inside the circle. That's the only case left to try for. Well, see, the problem here is that X is only half a unit away from the circle. This diameter is 8 units, and you got these leftover bits on both sides. So that's going to be 0.5, and then 8, and then another 0.5. So Y can be there, still outside the circle. And that's the greatest distance of the circle that you might have to cross, you know. Because if you think about it, all the other Y's that are 9 units away from here are going to form another big circle themselves. You know, it could be here, 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 there. I mean, those possible Y's are going to form a bigger circle with radius 9 around X as a center point. So that's how you know it's not going to ever hit this one, because a smaller circle is more curved than a bigger one is. So it's not going to come smack it over here. Right? So this is not ever going to happen, and you're going to get answer choice C. This case is not gettable. So C overall. So if you had a distance less than 8.5, as long as the distance was more than 0.5, the answer would be E. If it was less than 0.5, you'd be back to C again. Because then you wouldn't even be able to get over into the circle. So, yeah. Okay. This one seems to be less controversial. That's good. We got time to try another one then. Let's try. Same plane means that you're dealing in 2 dimensions so that you don't have to worry about 3-dimensional possibilities. So a plane, it actually wouldn't in this case, because being in the interior of a circle you'd still have to be in the 2 dimensions anyway. I think they just do that for bookkeeping purposes more than anything else. They try really hard to be very exact with their language, and sometimes it just gets annoying. Like, there's actually no reason to even say they're in the same plane, because being in the interior of a circle requires that anyway. But they just do it anyway, just to be super, super exact. So yeah, that's kind of how this is. Okay, one more, and then we will call it a day. And we're going to be our discussion of this one is probably going to be somewhat rushed. But let's see. On the circle is not in. On the circle would be not in the circle. It would not be in the exterior or the interior. It would be on it. It would be on it. All right, try this. Alrighty. Let's do this. A lot of you don't have answers, so let's try to get answers. And there are a lot of words in this problem, so it makes it annoying. So, because I mean, at first this might even look as though it were a yes/no type of question, you know, because you see greater than, and you might think, is it greater than? But that's not what it is. It's what percent. So, and revenue comes from units sold and selling price. So since you have those things, you might as well just throw that out there. The sooner the better. So you know that revenue times, selling price per unit times number of units, which in this case are sofas, is going to equal revenue. And conveniently enough, that gives us a table. So let's just take that and make it into a table. And then we have a this year and we have a last year. So, and then you want to find the percentage change in this column. So, and if you want to try to get 2 numbers for that. That's supposed to be a question mark, I'll fix it in a sec. If you can get 2 different numbers here, then that's not sufficient. And if you can get if you're stuck with a single percentage value, then that's sufficient. But this is what you're ultimately trying to do. You're trying to get 2 different numbers. So percent change. All right, and then let's actually make that a box in itself. Percent change, that deserves a box. Okay. So statements individually, it should be pretty clear that they are not going to be sufficient because they don't address one or the other key component. Like in statement 1, there's no information about price. And if you were not sure that whether selling prices could change, then, but statement 2 takes care of that uncertainty. By looking at statement 2, you can tell that prices are allowed to change. So the percent change could be anything at all. And then statement 2, you have no information about number of units sold. So we're down to C versus E together. All right, well, because again, your first case that you try can just be sort of random. So 10% more sofas. I mean, a really nice number to take 10% of is 10. So we could just have 10 and then 11. But then $30 more. I mean, you might be thinking, wait a minute, because in terms of percentages, because this is a 10% increase in the number of sofas. But this is, this all depends, right? If it's the Salvation Army thrift store where sofas are, 10 or 20 or $30, this could be a huge change. But if they're really expensive sofas, this might be an absolutely negligible change. So, just try those extremes. In general, testing extremes is always a pretty good bet here. So, I mean, if you had a thrift store where they used to sell couches in rather poor shape for $10, and then they made it $40, I mean, that's going to be a gigantic change in revenue. And that's going to be $100, and now it's going to be $440. So this is going to be big. It's like over 300%. But then let's say you're in this really, really schmancy store where you're looking at couches that are, $1,000. And now they're $1,030. You just stick with 10 and 11. Then this is $10,000, and this is, what is that, 11,330. And this is only between 10 and 20% change. So these are definitely different numbers. And you don't define them exactly to tell that either. So still not sufficient. And this is E. Overall. And that brings us to the end of today. We do have enough of these, I think, to make up another study hall. If the sofas were 30% more, then yeah, because you would get, because then you could do this algebraically. It would be like 1.1 times price, or times number, and 1.3 times price, and then you would get 1.1 times 1.3 times old revenue, which would be a constant multiple of it. So that would work. If you try to do this algebraically, you'll get, you can try to do that. Let's do this algebraically. In blue. So let's say that this is an old price and this is an old number. So the revenue used to be PN. And then that would be P plus 30, and this would be 1.1N. So that's the product of those. Plus 33N. So what you'd be looking for is the percent is old. The percentage increase is new minus old over old. So that is going to be, if you subtract the PNs, then you have, okay, it's 1.1 PN plus 33N minus PN over Pn. Those cancel out except for 0.1 Pn. So then you have, and then if you do the division, you get a constant plus a not constant. So that's gonna, you still have that 33 over P there. So that's gonna not be a constant. This is going to vary with P. Notice not with N, interestingly enough, but with P it will vary. So if you, and you might still want to, I mean, to me this sort of seems like voodoo symbols, and it doesn't really, this is not a very satisfying outcome for me, whereas I would much rather look at two values and see that they are concretely different. But still, having the ability to do both of these is always better than being able to do just one. So that is a thing. All right, we do have, some of these are left in the boards, so we will actually, we'll probably be able to do another study hall of these. If not next time, then soon. And then it doesn't vary with N because N is a percent change, and so that's going to make a constant contribution to the overall percent change. I mean, notice that will still scale with the price. Like if you had a 10% price increase and a 30% unit increase, as the other student said, then you have a like 43% overall increase or something. But sure. And I mean, that's the kind of thing when I think it was Pete asked earlier in the class about tweaking these things. That's why you'd want to do it. That's why just try changing stuff up like that and seeing how it works out. And it's, you know, illustrative. As long as you've got enough of a handle on the problem to be able to explore it without an answer key. But once you're at that level, then absolutely poking around possibilities like that is just going to build more knowledge. So, all right, and that's it. Good night and good luck. I'm going to stop the recording.